We're in a position now where we can become a bit more formal about the way we talk about our group decision-making methods. So what I want to do in this lecture is introduce you to the main components of the so-called social choice model. The main parameters are going to be a set N of voters. We always assume that there are only finitely many voters. And let's call the voters 1, 2, 3 up to N. So I'll use natural numbers to name the different voters. We also have a set X of alternatives or candidates. And recall that a relation on X is going to be is a linear order if it's transitive, irreflexive, and complete, where recall that complete means for any two alternatives, either the first alternative is ranked ahead of the second, or the second alternative is ranked ahead of the first. Let L of X denote the set of all possible linear orderings over X. And there are many cases in which we would want to drop this assumption of linearity, so we allow for ties between some of the candidates. So our voters may be indifferent between some candidates, or we allow our voting methods or group aggregation methods, group choice methods, to admit ties into the rankings. So let O of X denote the set of all reflexive and transitive relations over our set X. Now, we call a profile a listing of all of the rankings for each voter. So formally, a profile is going to be a sequence of orders over the set X. And if we're focusing on linear orders, then it'll be a sequence of linear orders. And if we allow for just arbitrary reflexive and transitive orders, then each of the R sub i's will be reflexive transitive orders. We're going to denote arbitrary profiles using a boldface. So R here is just a sequence, R1 up to Rn. Each Ri is a relation. It's an ordering, preference ordering over the set X. So Ri represent voter I's preference ordering over X. Let Lx raised to the nth power there denote the set of all profiles for n voters. And similarly, if we're interested in just arbitrary reflexive and transitive orderings. Now, if we fix a profile, so we have some profile, and this is just going to be each of the Ri's are reflexive or transitive orderings. Let's let N of APB denote the set of all voters that rank candidate A strictly ahead of candidate B. So that's what this notation P sub I means. Recall that if we have a reflexive and transitive ordering R sub I on X, then P sub I denotes the strict subrelation of R sub I on the set X. So NR of APB means that it's the set of all voters that rank candidate A strictly ahead of candidate B. Similarly for indifference, so AIB stands for candidate A and B are indifferent. So this is the set of all voters that rank A and B at the exact same level. And NR of BPA is the set of all voters that rank B strictly ahead of candidate A. Now, the way we're going to think about a group decision-making method is as a function. We're going to identify some set of profiles. These are going to be the profiles under consideration. And then a group decision-making method for that set of profiles is just a function that assigns or associates a linear ordering to each profile in the domain. So group decision-making methods are understood as functions. So a few comments about this way of thinking about group decision-making methods. First of all, D is just the domain of the function, and note that in general, we're not assuming that the domain is necessarily all possible profiles of linear orderings over the set X, but rather just maybe some subset of that. Second, the aggregation methods or the group decision-making methods are assumed to be decisive. What that means is because we're thinking of these group decision-making methods as functions, that means that for every profile in the domain, the group decision-making method has to assign or associate with it exactly one ordering over the set of candidates. So it means that our group decision-making method can't just throw up its hands and say, gee, I don't know what ranking should be associated with this. It's too complicated. I don't know. I don't have an answer. And also, it can't try to associate two different orderings over the set of candidates with one single profile. So group decision, it's important. This is just to say that group decision-making methods are conceived of as functions. Note that the way I have it set it up here is that the range of the function is L of x. The social orderings are assumed to be linear orderings over the set of candidates. And basically what I'm assuming here is that we can build in any tie-breaking rule that we impose into the definition of the function. But we can vary some of these assumptions. So in particular, one natural way to vary this assumption is rather than forcing the group decision-making method to give you a full ranking over the set of alternatives, we might not actually care about the ranking. All we care about is actually who wins the election, who comes out on top in the ranking. In that case, we tend to call these social choice functions. And a social choice function just assigns to every profile in the domain some subset of candidates, and it has to be, this just means non-empty, so it has to be at least one candidate has to be associated with every single profile. Another way we could vary this basic definition is we could allow for ties. So rather than having the range of our function be the set of linear orderings over the set of candidates, we allow it to just be the set of reflexive and transitive orderings over the set of candidates. So we allow the group decision-making method to allow for ties. We could also allow our voters to submit ties or allow our voters to be indifferent between the candidates. So our group decision-making method F would be a function from D to O of X, where D now is a subset of, this should be O of X to the N, set of profiles of reflexive and transitive orderings over the set of candidates. So here's just two examples. The first is our majority relation. So given a profile, it associates with each profile the majority relation, where the majority relation is defined as A is ranked ahead of B if and only if more people rank A ahead of B than B ahead of A. The problem with this, of course, this doesn't fit our definition. This doesn't even fit our definition of being a social welfare function, because this ordering may not actually be transitive. This is the so-called Condorcet paradox. Another example is Borda count, where one candidate is ranked ahead or at least as high as another candidate if the Borda score of A is greater than or possibly equal to the Borda score for B. The problem here is that this ordering may not actually be a linear order, because in many situations, two candidates may be assigned the exact same Borda score. But Borda is a function, so Borda is a function from, let's say, L of x to the n to the set of orderings over x, because Borda is going to produce a transitive ordering and a reflexive ordering.